Good morning, everyone. I am Esmond D'Souza from third year Information Technology, and this is my friend Sunit Almeida. We welcome you to Encore 2015, which is an online paper presentation. It's been held from the past 3 years in our college, and due to the increased response, this year we made it a national event wherein the individuals can present their papers from different parts of our nation.
Today, we are lucky to have in our midst Mr. Vinayak Tendulkar. He is a consultant at TCS. He has more than 15 years of experience in the IT industry. He has played various roles in IT sector, particularly in service delivery, including project and account management, solution architecture, pre-sale leads. He is the pre-sale head in TCS open source technology domain. May I ask our HOD, Mr. Shiv Negi, to hand over a bouquet to Mr. Vinayak Tendulkar. Today, we also have in our midst Mr. Suhas Nayak. He is the assistant consultant at TCS. He has more than 12 years of experience in IT industry. He has also played various roles in IT sector, particularly in service delivery, including project and account management, solution architecture, pre-sales lead. He is the team leader of 10 members for a strategic initiative for TCS Corporate. May I now request again our HOD, Mr. Shiv Negi, to hand over a bouquet.
So we start with our first paper, and the title is Visualization of Mechanics Problems Based on Natural Language Processing. We have the author names as Aditya Nayak, Amanpreet Singh, Bharat Gelana, Narayan Acharya, and Avni Sakhaphara. The paper ID is IT 014.
Hello, Narayan. Can you hear me? Hello. Hello, Narayan. Hello, Narayan.
Hello.
Hello, Narayan. Can you hear me?
Hello.
Hello. Hello, Narayan.
Hello.
Yeah. Can you hear me?
Yeah.
Yeah. Can we start with the presentation?
Yeah.
Yeah. Just full screen your OVO desktop.
Just a second.
Acha, the procedure is you have 15 minutes for presenting your PPT. After that, 5 minutes is allotted to the judges for asking the questions. You cannot go beyond that. Okay. Just please full screen your OVO thing on the right hand side from video call. Yeah. We did that in the testing part, right? On the right hand side, video call, the first option.
Hello. Am I audible?
Yeah, you are audible. Okay, you can start with the
Shall
presentation.
I start?
Yeah, you can.
Yeah. All right.
Are please full screen.
The PPT is visible, right?
Yeah.
All right. So our paper is based on visualization of mechanics problems based on natural language processing. The team members, as you can see on the screen. So now, basically, we had to choose an idea for our B project. So We came upon a lot of ideas, but finally we chose a text-to-scene generation system because we thought it would be how awesome it would be if the written text can be converted into graphics directly. So our system basically is a text-to-scene generation system. It will take the input in natural English from the user and it will convert it into a graphical scene. Since the scope is varied, so we narrow down our scope to physics mechanical problems. Now, earlier on, the systems that have been implemented like this are the put system that was in the 1970s. That system used to take three inputs like two objects and the relation between them, supposing a ball is on a desk. So a ball, the desk, and the on preposition will be given as the relation. That was the initial system. Then there's the cards and system, which is a basic accident report generation system. The police officials enter an FIR describing an accident scene and it is generated graphically. More recently, the wordseye.com is in the prototype stage, which has a library of around 3,000 objects, which can be rendered based on natural languages. Now, to take you over the implementation part, Narayan will take you.
Hello. Hello. Yeah. So, how do we propose the system? So, here is an architecture diagram of how we are doing this currently. So, first we take in an input question. The question is expected to be in natural English language and grammatically correct. That is required by the system. The second step is the parsing and dependency building. The next step is the questions that are taken in by the system are parsed and particular tokens. There is a step called tokenization, which tokenizes each and every word along with its meaning and its grammatical reference. The dependency building step is where each word is related to the other words in the sentence. The next step is the parallel processing of the objects and their spatial representations and information extraction. The first step over there is the objects and their spatial representations. The objects that we identify are taken in as either they are as renderable, as in they need to be represented in the graphical scene, or they are not. And the next step over there is information extraction. And over here, we use information extraction techniques to remove data. That is like this ball is moving with the speed of 10 meters per second. So data like speed equals 10 meters per second or something, or any data that refers to physical quantities like speed, acceleration, mass, etc. Finally, these two modules are then passing on their data to the rendering module. Over here, the rendering module uses an object repository as a reference to see if that objects are present in our database of objects that we've created, and using the spatial representations applies appropriate transformations and passes it out to the rendering module where the output is rendered. So what is natural language processing? Natural language processing is applying information extraction techniques on regular language. We've done this on English language and it has various applications ranging from information extraction to machine learning and stuff. So next is the rendering awesomeness. Now over here, we've used Java 3D API in order to render our outputs and our scenes onto the screen. Again, as I said, we use the parsing and the object spatial representation in order to inform or notify the rendering module how to render it. So over here, we've used Stanford NLP as a rendering as our natural language processing library. Stanford NLP is a very sophisticated library in order to do natural language processing on various languages. Mostly it is done in English. Uh, uh, One second. The Stanford NLP uses a pipeline. The pipeline consists of various properties that need to be set, like annotation, tokenization, parsing, NER, that is named entity recognition and stuff. So that needs to be configured in order to make it specific to one domain, as our domain is physics, mechanics problems. And from there, we use our normal NLP techniques in order to get out information from the input question. So for example, let's just take in a simple sentence, a ball is rolling on the plane. Over here, the implementation dictates the output to be a plane that is rendered and a ball on top of it. Over here, the objects identified are the ball and the plane, and the preposition on is used as is used for the applying appropriate transformations, like in this case, translation. So this is an actual output of our system that we've implemented. Our system has an accuracy about 60% that we tested on a corpus of about 20 to 25 questions. So what's next? Now over here we are taking our implementation to another levels, like making the system self-learning. Using the corpus of questions, we'll be making the system self-aware about what to input, rather than making rules about where to place this stuff. The system will be learning as per input questions are given to it. Also, there are other applications of this. Like for example, if you are given a PC configuration about what hardware and what software that needs to be there. So over there, once you have the configuration, NLP techniques can be used, and the CPU unit can be seen. Other implementations can be used for police technologies, where you are given the face description of a criminal suspect, and thus his face is kind of created by the system. It can also be used in educational domain, where professors and students both can use this in order to visualize what their mechanics, or be not even mechanics, be it other problems. The system can be configured to move it into other domains also. We are also planning to make animation as an integral part of the system, where stuff like moving, rolling, running, jumping, etc. can be incorporated into the system. So we've used a lot of references in our implementation. First one is the put language system that was to you by Aman earlier. Also, we have Stanford NLP, we have GATE. GATE is General Architecture for Text Engineering, that we compared Stanford NLP and GATE in order to choose which one to select. We finally stuck with Stanford NLP due to the steep learning curve for GATE. Also, we've used Blender in order to build our software models that are like the one you saw, the plane, the ball, etc. Thank you. Would you like to see a demo of our system? Okay. 1 second. Uh, 1 second. Actually, there is another team waiting here, Dharin Shah's team. They need to go for an exam. If you could conduct their presentation first, I'll show you the demo later. Okay, so yeah, the questions. Yeah, you can go ahead with the questions.
Yeah. So first question is, since you mentioned you have used English as a best language for input, what is plan for having multiple languages as an input?
Currently, we haven't expanded our scope into multiple languages. We are sticking with English as our scope was restricted to mechanics problems, and generally English is a medium generally taught in schools and colleges. So we are stuck with English for now. But also there are
just-
other
just wait.
also there are other restrictions.
Hello.
Yeah.
Just wait. Huh?
Yeah. Okay. Okay. Sorry.
Yeah.
Actually, there are other restrictions as well, as in NLP processing techniques. They haven't been, they aren't much accurate for other languages, for say German or French or something like that. NLP techniques are accurate currently for English, so that's why we are stuck with English right now.
Okay, because I feel localization will have more specific input or a deviation or variance when you are parsing the text. Okay, localization meaning specific words being used or the meaning of object. Hello, can you hear us? Right?
Yeah,
Yeah.
yeah.
So I know Stanford NLP also has some kind of localization repository built in.
Yeah, it has support for other languages, but they are not as accurate as we require them to be for our project.
Okay.
So
Right now your accuracy is 60%, right? You mentioned.
yes.
So uh, what are the challenges in terms of making it 80% or 90%? Have you studied that?
Yeah, currently we are implementing a rule-based system, as in there are certain rules that need to be taken care of. So if we could make the system self-learning, the accuracy can be improved. But as if suppose a question that does not follow a particular rule, so that if it does not fit into our rules, then it might not be rendered as required. It might do the NLP right, but it won't render it accordingly. So we are planning to move it ahead and make it a more self-learning system than just a rule-based system.
Okay, so don't you think you need to build repository in advanced mode? Right now, you have some thousands of repository objects, right? Don't you think you need to increase that number of objects in the repository?
Yeah, we need to. But actually, if you see Words Eye, that is one of the best in text to scene generation system. It is in beta since 10 years, and still they have a very moderate or crude repository currently. So repository building might take up a bit of time. Currently, we are more focused on making the system self-learning and self-aware about how to appropriately interpret questions. So that is our current focus.
Okay. So,
I just have one question considering the time. Are there any commercial
Yeah.
applications or applications being developed by corporations on similar lines of what you have designed? Can you just throw some light?
Uh, yeah, there is not exactly similar, but there is somewhat similar implemented by Morgan Stanley. They are trying to build a similar system. They have actually somewhat to make education a better experience for uh, differently able children. So they are currently into that domain as their uh, implementing it in that way, making education easier for differently able children.
Okay, fine. Thank you.
Thank you.
we are done with the question.
Yeah.
So you can go ahead and go for exam and remaining.
Can I show you the demo now, or is it okay if I show it later? Okay. Yeah, yeah. Okay, thank you.
The next paper for today goes by the title Classification of Music Genre Using Neural Networks with Cross Entropy Optimization and Soft Max Output. The authors are Dharen Shah, Chirag Sachdev, Bhavik Shah, Shailaja Gogate. And the paper ID is IT029. Hello, Bhavik. Hello.
Yes, sir. Bhavik.
You can hear me?
Hello, sir.
Hello, you can
Yes,
hear
sir.
me?
I can hear you.
Okay.
Yes,
Some
sir.
instructions for you. The time limit is 15 minutes for you to present your project.
Okay.
After that, the judges will be
Okay.
asking you questions. Can you start with the PPT right away? You know how to share
Yes,
your
sir.
screen, right?
Yes, sir.
Yeah, yeah. Just start with
Sir,
the PPT.
okay. Okay, sir. Yeah. Sir, our project is based on the
Wait, wait.
classification of musical genre. Okay,
Wait.
sorry, sir. Okay, sir.
Okay, you can start.
Sir, our project is based on classification of musical genre using neural networks. Sir, basically, what is musical genre? Sir, in simple words, we can say that a genre of music is a form of a label that determines a shared tradition amongst the group. Sometimes musical form and music. Yes, sir. Hello. Yes, sir. One second. सब लोग को लेके जाना है यहाँ आवाज मत कर कैसा यस सर सॉरी सर या या सर या सर या नाउ आई कैन am I audible sir yeah sir then our project is based on the classification of musical genre using neural networks. So basically, what is musical genre? So in simple words, we can say that a genre of a music is the form of a label that determines a shared tradition amongst a group. Sometimes musical form and musical genres are used interchangeably. So the genres we have used for our project is classical, jazz, rock, and techno. So what is the need for classification? So there are billions of untagged musics in the digital format into archives and playlists. Therefore, it is necessary to design a classifier model which automatically classifies the music according to its musical form or the genres. So the model. The system uses the machine learning approach wherein the data to be classified is inserted with the correct label so as to optimize the classifier. And so this is known as supervised learning. So ANN, the artificial neural network, is the state-of-the-art technique for supervised learning approach. It is modeled by mimicking the brain's ability to recognize and generalize patterns by extracting the features with a sensory system. The nonlinearity activation functions enables neural networks to classify complex data sets. Sir, next my friend Dareen will continue from here.
Hello. Hello, sir. Sir, am I audible, sir?
You are perfectly audible.
Hello.
Please continue.
Yeah. Okay. So, sir, we require the features for our neural network. Now, it would be a lot easier if we supply the audio waveform as a feature in the neural network. But then the problem with this approach is a single music file will be too large for efficient computation of the weights. And without transformation to different dimensions, basically we need a change of basis for the classifier to generalize the pattern. And therefore, extracting different features with less correlations is necessary to correctly classify music. The feature extracted and detailed information I will show it in the next slide. These are the features which will be extracting from the audio files. Now the features are dynamics, pitch, timbre, and rhythm. And dynamics, we will be extracting RMS and low energy. The this description, as you can see, the RMS value is the average global energy, and low energy is the number of values below the average RMS value. That is basically the percentage of frames showing less than average energy. Now, sometimes the music files, different genres contain different kinds of energy, and the temporal distribution of energy varies with respect to time. So, why are we extracting this? Is because the only reason is that the different genres contain different distribution of energy. Pitch is required to know the pitch, and in pitch we are extracting range and number of notes. Range is difference between highest and lowest pitches, and number of notes and number of pitches played at least once. And timbre, we need to extract roll-off, brightness, and irregularity. Roll-off is basically the cutoff frequency in which is above which the most high frequency components exist, and brightness is the energy above certain frequency which we supply to the function. Irregularity is the degree of variation of successive peaks of the spectrum. Sometimes different genres, it happens is the successively it does not harmonically it is not harmonic some genres. Therefore we need to extract irregularity as well, and we are testing it on our prototype model. And the rhythm is the main dominant part of our feature extractor, since rhythm contains the genres are basically described based on the rhythmic content of their rhythmic content basically. And the rhythm, as you can see, there are multiple types of extractors in rhythm. The learning model we are using, it's primarily a feed-forward neural network, and with its different variants, we are going to test it with its different variants. The learning algorithm employed is backpropagation, and logistic sigmoid is our activation function with softmax output as our final layer activation function. I'll tell you about softmax output function in the later slide. As you can see, the model neural network model is shown on the screen. Why neural networks? This question we need to ask when we at the start of the project. Now, neural networks has many variants, but primarily it's a low bias classifier. Now, low bias classifier means it does not assume any hypothesis. It does not pose any hypothesis on the model. Therefore, we need to generalize. We don't really know how if it's a linear fit or non-linear fit or non-linear function can be a good classifier. Therefore, we are using neural networks so that it will automatically generalize. It will automatically create a general pattern. Now, it is a simple model with non-linear activation function. It scores over SVM support vector machines because we need a model to be performance friendly. And artificial neural network is relatively easy to understand, and therefore coding a neural network becomes a trivial task. And it is generally great for prototype and drawing inferences. If we want to, and for further studies, it is helpful for us to draw inferences on what we are actually aiming and what we are actually gaining from the results. Now, the optimization function. The optimization function is basically is generally how the errors are reduced. It needs the weights need to be on the global or local or optimal level. So we use mean square errors are optimizing function everywhere. But in problem with mean square error is the mean square error disadvantage bias. This is the result of sparing each term, which effectively weights large errors more heavily than small ones, and hence high gradient even for small absolute error. The constraint encourages us to use cross entropy optimization function, which overcomes drawbacks of MSC along with being faster in terms of performance. It requires less epochs, experimentally shown. You can see the function and softmax output, as I told you before. Softmax output basically is it will show the probability distribution across the genres. Basically, it will normalize the output weights, and it will show output weights, and it will show the distribution, probability distribution. So it is between the output is between 0 and 1, and the distribution between genres will basically will show the probability distribution between genres. It's an empirical distribution. And the further optimization for feature extractors we are using, we did is the feature extractors are not selected arbitrarily, but we may find some irregularities. So a group classifier output will depend on high number of principal components in the feature. PCA is a dimension reduction technique which primarily projects the data into lower number of dimensions by finding the principal components in the data. The principal components are ones which are highly uncorrelated and therefore contribute to good classifier. But however, PCA does not guarantee good fit, and sometimes some features that may contribute to good classifier are removed, since PCA only does linear transformation data and does not consider complex relationships between data. Therefore, here comes the autoencoder. Autoencoder is basically a three-layer neural network where output units are directly connected back to the input units. Since the output is directly connected to input, and as a result, when we pass the data through this network, it first encodes, it first compresses the input and to put in a smaller representation, and then tries to reconstruct it back. So, if we, for example, if we put if our feature number of features 16 and the number of hidden layers are 10, then it will compress the data into 10 vector with length 10, and it will help us reduce the number of dimensions of the data. The task of training is to minimize an error or reconstruction that is find the most efficient compact representation. This is our system. Now my colleague will continue.
Hello, sir.
Yeah, we can hear you.
Okay, thanks. So I'm Chirag. So hello, sir, and I'll be continuing the test cases part, sir. So making the system is important, but the major part is testing and how useful it is. So the test cases, these are randomly divided from the whole training set, sir, and they consist of 15% of the training set. And we are considering 400 files for the training set, which are divided as the 4 genres, each genre having 100 files. Okay, sir, and the validation data consists of other 15% of the training sets. So these are the results by the auto encoder. So as you can see, the successful part, sir, is a 34.8%, and the error rate which we are getting here is for 65.2%. And the 1, 2, 3, 4, they are the output classes for each genre, sir. You can see 50%, 50%, 25.7, and 74.3, and 66.7 and 33.3 for the 4 genres, and the average is 26.8, 73.33, the error rates, which is very bad actually. And due to this defect or the bad output, we use the 2-layer neural networks. These are the respective matrices. For first one is for the training confusion matrix. Second one is for the validation confusion matrix. Third is for the test confusion matrix, and fourth is the all confusion matrix. As you can see here, so the output is better. You can see in the training confusion matrix for the first genre, so it is 68.4%, while the error rate is less as compared, that is 31.6%. These are the respective confusion matrix for the 3 ones, and the final one is the all confusion matrix, where we have the better results in the final ones, where 71.4%, 28.6, 70.5, 29.5, 75.3, and 24.7, and finally the 83.5 and 16.5, where the average is 74.8 and 25.2%. This is the graph which we have plotted for the average percentage error. The first part is for the training set, sir. The second is for the validation, and the last one is for the testing. And pass 1, pass 2, pass 3 for respective training, validation, and testing, sir. So these are the technologies which we have used. That is a MATLAB tool and the MIRR toolbox, which stands for Music Information Retrieval. Thank you, sir. My friend Dharim will continue, sir. Hello.
Yeah.
Yeah, sir.
You finished, or you have something to show?
No, we are finished. We are finished.
Okay. So, couple of questions.
Yeah.
So, tell me one good example of applying this in a real practical scenario. Or should I explain you a use case and you can explain me how it will be used?
It's fine. It's fine. I'll explain you how we can apply this into our different kinds of software. We can just use the neural net that's the best trained in neural net, and we can use it in our
one second.
different.
One second.
Hello. Yeah. Okay. Fine.
Yeah.
Okay, so we can use this in different kinds of applications where music is related. So in different music players, we can embed this our trained neural net and the out and extract certain features which we have extracted and use it to determine the genre of the music if the neural net is best generalized.
Okay, so apart from this particular application, let me give one use case. Okay,
Yeah.
I have set of recordings of criminals. Okay,
Criminals. Okay.
criminals. Okay, it is stored in the repository, and
Okay, fine.
there is an input coming from let's say cellular network. Okay, for example, Airtel, Vodafone, or any other telecom company, and that is coming as
Okay.
an input to your system. Okay,
And we
uh,
want to determine the
we,
who's the criminal is.
we want to compare, okay, the
Okay.
repository against the input, and from your confusion matrix, can it show the percentage of okay, you got it.
Yeah, yeah, yeah. For this kind of application, we need different features because speech recognition is a different application than determine a genre of music. So in speech recognition, we can compute the spectrum MFCs and we can train it against the repository, and then we can use it to determine who the criminal is or what kind of whose voice it is.
Instead
To
of
train it better.
instead of music file, it is a recording. Okay, so
Yeah, the
basic,
difference is the features. We need to determine which features are there. The feature part is it's on us.
right. So you need to compare the existing parameter, what you are comparing in your matrix. Okay,
Yeah,
different
yeah,
dynamics. Same parameters you can
yeah.
compare, and you can show input versus the repository. You have to pick which is the best fit recording from repository against the input.
Yeah, I get it, but in our application, it requires the rhythm patterns and other features which are exclusive to audio files and music files. And therefore, when we try to apply this on different kind of applications, we need different features. And therefore, in applications such as this, if you're telling, which you are asking me, we need features which are based on humans auditory system. So features like MFCC, as I told you, is better. It's better if we use the features like MFCC and train our model, and then it will be for us to classify the output.
Which component of your architecture, okay, which will undergo the change?
The feature extractors would be the major component, and then after that, if the results are not overwhelming, then we need to change we need to use the different variants of neural networks and test it against different variants of neural networks.
Fine, thank you.
No, nothing for me at this stage. I think it's pretty clear with what my colleague has asked. Thanks.
Okay, hello.
Hello, yeah,
You can stop your presentation. Huh? You can close the window.
yeah, okay,
Thanks.
okay, thank you.
So our third paper for the day is on Moodle plugin for data summarization, and the authors are Professor Shiv Negi, Aditya Singh, Amish Advaryu, Vicky Fernandez, and Chirag Gohil.
Yes, sir. We'll start. Yes, sir. Okay, sir. Yes, sir. 2 minutes. Good morning, everyone. Today we are going to present you a final year project that is Moodle plugin for data summarization. We'll start with the current scenario, how our project works. Basically, Moodle is a content management system designed by Moodle.org, which is used by universities and colleges across the globe. What Moodle does is it provides a platform for all the teachers and the students to share quizzes, assignments, practicals, and notes on a single interface. So, as a teacher, I can share my notes on the interface, and the students can download that from there. Then they can attempt the quizzes, assignments, and practicals. And on the single interface, the teachers can grade them depending upon their submissions. As a system, Moodle is quite complete, but there were a few drawbacks which we encountered in the past few years. First of all, what Moodle does is it has all the operations that are performed on the system is related to the database which comes with Moodle. That is, if I'm giving an assignment on Moodle, the grades which will be generated will come from the database that is with it. But if suppose every college today has a separate college management system, in our college it is named as Colmission. What happens is, if suppose there are some activities which is happening offline, for example examinations. Now in such a scenario, the marks which are graded offline are stored in that respective college management system. So there wasn't any plugin or interface which can actually join both the systems, that is a college management system and Moodle. So what was happening is Moodle was acting alone and the college management system was acting alone. It was like an isolated entities. Now due to that, that was the first thing. Second thing was, in Moodle, if suppose there are practicals and assignments which are graded by the respective faculties, in such a case, the report which was generated, in such a case, the report which was generated was regarding the whole class. That is, if suppose the system, if the course has around 100 participants, the report will be generated based on the average performance of all the participants. So what we thought was, we'll make a individual kind of thing. That is, we'll get all the participants' name on a single interface, and when the teacher clicks on a particular participant, we'll get all the data from Moodle with respect to that participant, and we'll display that on the particular page. That is a PDF report having everything related to that student on the Moodle database. Now the thing was, if suppose a student has attempted 10 quizzes on the Moodle system, when the report is generated, the system will only take into account the 10 quizzes which the student has attempted on that system. But we are not getting the things which are happening on the offline mode. So we made a plugin to actually join the two systems. That is the first plugin which we created. Now the second part of our project was, if suppose I can get all the data from the Moodle, from the student management system to the Moodle system, still there was a drawback. That was a standardization part. If suppose I'm making a plugin which works on my college, but if we are going to make a plugin which works on every, because the problem is universal, Moodle is not able to sync its data with an external database. So what we thought is, we'll make such a plugin that will be standardized in its own form. That is, if suppose there are some data
stored in Moodle database like name, roll number, address, and things like that. We'll get a standardized kind of database for that. We'll get the data from the college management system into that, and then we'll update the Moodle database. But the challenge was the Moodle architecture. Moodle as a CMS consists of 545 tables, and the data which is updated there is not very segregated, because if a roll number is changed for a particular student, it is present in around 12 tables. So you have to take into account when you are updating a roll number from one system to the other, you have to update that on all the 12 tables, or there might be some inconsistency, which will lead to some failure. So that was one challenge which we are facing. Second thing was, since the college management system database will be present on a separate server, so we have to link both the server and then get the data in a proper format. We cannot have garbage collection into our database, because there might be some inconsistency in the primary database as well. So that was the second challenge for us. You can see the system architecture for Moodle. This is a magnified view of the system that we have created. As I told, Query Maker is a plugin which we created. It is actually linking the external database and storing it into another database that is an intermediary in a standardized format. That is, if suppose a student has hundreds of records like father name, father email ID and all in a student management system, but we don't require that in our Moodle system, so we are not going to take that. To cut down the entries, we have made this Query Maker to store everything in a standardized format. Once it is stored in the standardized format, the Query Maker will again take that data and store it in the Moodle database and update it in all the 545 tables, so there is no inconsistency. Once it is done that, we can create an individual student report which can be exported in two formats, that is PDF and XLS. There are some modules which we are going to explain. The first one is the DBIT student report. As I told, Moodle as a system did not have this functionality to generate an individual report in which there will be data present from the Moodle database, as well as details such as roll number and test marks, which from student management system. So we made this part. You can see this is a sample report. As you can see, name, class, roll number, ID. Now these kinds of data is not present in Moodle. So we are actually fetching all these data from the external database and then storing into the Moodle system. And then we are showing such. This is another sample report, as you can see. Now the assignment, submissions, quiz, test, performance, these two things is stored in the Moodle database, and the things like name, class, roll number, and ID is coming from an external database. So this PDF document actually fetches data from two different systems. The Query Maker. This is one specialized thing which we make because initially when we started, we had to make a system which worked on our college. But then we realized that we have to make something standardized. So Query Maker, what Query Maker actually does is, it will store the data. It won't fetch data which is not required in the Moodle system. That is, every college has some kind of data regarding students. Then there is data regarding the parents, and these kinds of data regarding parents and all is not required on the Moodle system, because Moodle system as such is a simple college management system. It will only require data regarding the student. So Query Maker will only fetch data which is compatible with the Moodle system. So this is, as you can see, this intermediate interfacing entity is used to achieve a standardization between the two systems, the learning management system and the student management system. This is the flow of the Query Maker, as you can see.
The data will be brought in from the student management system into the Query Maker. It will be stored in the standardized database, and from there it will be exported into the learning management system, which is Moodle. This is a basic difference between what is already available in Moodle and what our report generation plugins will do. Basically, the report generated in Moodle did not contain data about student roll numbers and unit test marks. Our reports will contain those data as they are brought in from the external system. The internal Moodle API have very poor documentation. So using the PHPs that Moodle uses internally and modifying them to our requirement was a tough task. So we decided to start from scratch. We have only used APIs that have good documentation and basic PHP so that they can be developed further. Implementation. This is how we install the plugin into the Moodle database. This was the very first challenge that we faced, that letting our plugin get detected by Moodle and allowing it to be installed. So we just copy paste the folders and the files into the appropriate directories, and if the appropriate information is present in the predefined files, it will detect it. Even as I said, the documentation when we made it was very poorly available. We had to scour the internet for searching the information. This is the success message of the plugin getting installed. This is how it will be visible in the management of the plugins in Moodle. Now, as you can see over here, there are 2 courses in Moodle currently installed in our demo Moodle installation. We have logged in as admin. To install to access the sync button, we add a new module, and to view the reports, we add a new block which will be visible over here to teachers and admin. This is the list of the students that are currently enrolled into that particular course. Currently in the screenshot, we don't have any users, just the admin has been enrolled. Then we can export it to PDF and XLS. The Query Maker interface. Now we can access the Query Maker interface in the site administration in following the tree structure in the development Query Maker. It installs as an admin utility. This is the interface of the Query Maker where the admin has to allow access to the remote server. You can see the external server location. Here we can enter the IP address of the local host, the username, password, and the database in which the student's external information has been stored. This is the interface. The interface has been divided into 3 parts: the navigation bar, the function buttons, and the action. This is how the mapping will be done. As he said, only the fields that are required are in the Moodle are viewable as column names. For example, if we need student ID in the Moodle database, then we have a standard table, student info, in which the student ID is as a field. Then we have an option to map that student ID to any table and any attribute of in the remote database. A query will be generated using the Query Maker, which will be used to fetch the data and insert it. We can also add a where clause using the where button, which will allow join queries and specific queries to be run. This is a view of what is already what will be mapped from the external database into the Moodle database. A query was the previous query that we generated that is being executed over here. We can also, suppose we cannot map the entire database in one query, then we can execute multiple queries using new rows. So we can add as many rows as we want, and all those queries will be executed consecutively. This is a display of how the where clause can be added, and you can see the query generated by the Query Maker. We can also save and load the configurations so that the admin need not do tedious tasks such as mapping the whole interface, mapping the whole database to Moodle again. Once it is mapped, we can save it and load it as and when required. Result. We have generated the plugin and it is working. We have tested it for about 100 records. extensive testing is under, we are still on it for load testing and things. And these are the references that we used.
All the references are actually the Moodle.org site. We don't get any help from the other websites because it's still in the development phase. As you can see, all are docs.moodle.org. The system architecture design, which we have got. Thank you. Can we have any questions, sir? Yes, sir. Yes, sir. Wait, sir. Yes, sir. Yes, sir. Yes.
Yeah. So first question, since you mentioned, okay, API, Moodle API is not that
Yes,
great
sir.
in terms of documentation. Okay.
Yes, sir.
There are two questions. One is how flexible your current query maker module with respect to uh, incorporating, let's say, custom non-Moodle systems in colleges. Okay, for example, for storing
Yes, sir.
offline exams or any other, uh, let's say, event-based results for students and all related data, or any feedback mechanism from parents or feedback mechanism from other students, okay, or quizzes. So there will be multiple systems and there will be multiple databases that it will have. All right. So can it take all these databases as an input to query maker and have a centralized database?
Yes, sir.
That is one question. Okay. And how flexible it is.
So, okay, okay.
And another question is, since this plugin you have developed, I think it is current version is what, 2.4?
Yes,
Moodle?
sir.
Yeah. So
Moodle.
yeah, Moodle.
2.6.
So, Moodle is 2.6, sir.
Okay. So tomorrow, if Moodle 2.5 comes in, right, how this
Mhm.
plugin is going to work? That is the second question.
Okay. So to answer your first question, first of all, when you take into account quizzes, as I already mentioned in the presentation, currently we are able to um extract data such as offline unit test marks and prelim marks from the external database to the Moodle system. So it is already functional. If you talk about the development part, that is in the future, if someone wants to develop it further, so there is a way, in the sense when you start the project, Moodle specifies a way of coding that you have to follow. That is a standardization, Moodle standard way of coding. So we have followed that. So if in the future anyone wants to understand our code and he or she understands the way Moodle works, I think it will be easy. It will be a challenge, that's for sure, because you have to understand the architecture, the database design, how Moodle actually stores the data. So that is one part. Secondly, if he or she is able to understand that, then it is possible to develop it further, because we have taken into account, we have made this plugin for our college. So there might be a requirement in the future that we have to actually edit this plugin and do it according to the future use. So that is one part we have taken into account. Second, so you talked about plugin. Even though we are using 2.6, that is the latest version of the Moodle, we actually made this plugin to be working for systems on 2.0 and above. So in the future, if suppose in a particular college who are using Moodle version 2.3 or 2.4, it will work perfectly fine. It won't work below 2.0 because we have to follow some standards. So that is one thing. It can go up to 3.0. That is the flexible, that is the way we have coded. There is a version kind of thing, sir. When we made, there is a version.php file which we actually construct during Moodle thing. So in that, we take into account how much our plugin can work in different circumstances. That is, when you're installing a Moodle 2.0 system, how it will work. If you're installing a Moodle 2.8, that is the latest version, how it will work. So it will work completely fine for 2.0 and above.
Another question is, Another question is, since there is certain set of attributes in Moodle, okay, is common. For example, let's say student ID, roll number, which are very very common
Yes, sir.
and
Hmm.
generalized for all the colleges, right?
Yes,
Uh,
sir.
have you thought about making that standardized and storing in a separate database altogether? Okay,
Actually, sir.
which is linked to Moodle.
Okay, okay. Actually, sir, we are doing that. That is in our thing, the query maker thing. What it does is will fetch the data from the student management system. It won't directly take it to the Moodle system. It will first store it in an intermediary thing, standardized table.
Right, that
Then,
is that.
when the standardized table will have the
Sorry, yeah. So
hmm.
I understood that you are taking from a
Yes, sir.
non-Moodle system and making it standardized.
Yes, sir.
I am talking reverse way. Okay,
Okay.
taking it from Moodle and keeping it at central place and making standardized.
Okay.
Okay, so that if some systems in colleges don't want to interact with Moodle, still it can use that.
Mhm.
Okay,
Sir,
have you
it will
thought?
be a challenge actually. They will have to understand the whole Moodle system and make queries based on that and then fetch the data into standard format. So it can be done, but it will really be a challenge.
So it is quite possible. The problem is we cannot make that because Moodle, if a college is situated in US, they will use the same Moodle system that we are using. So when inserting data into the Moodle system, it will work as it is like us and the US part. But when you are taking the data from Moodle, storing into an external database, then doing it in the reverse order, their own college management system will be different from ours. So it is like you can store the data to an external database, but you cannot do the exact reverse. You cannot store that data into the college management system of that particular college. It is possible. We have not done that in our case because we are working on this direction. But that is quite possible, sir. If you are able to understand the Moodle architecture completely and then fetch the data regarding that.
Okay, because this module or plugin will be, I would say, complete if reverse way is also possible. And tomorrow, let's say regional specific college management systems don't want to share the data between regions, but at the same time, it has to use a common Moodle information to generate specific regional reports. Okay, but it is good. Another question on the architecture side. Okay, you used PHP and Apache, right? And
Yes, sir.
right, you mentioned about some 500 odd tables,
Yes, sir.
correct?
545.
Right, and it is being stored in MySQL, if I am
Yes, sir.
right.
Yes.
Uh,
Yes, sir. It is. Yes,
have
yes.
Yeah. So have you thought about taking out some data from those tables which are frequently accessed but not
Hmm.
frequently changed? Okay, for example, once roll number is created, he will be there till he is there in the college. Okay, or
Hmm.
similar, which is not frequently changed, but it is frequently accessed. Okay, have you thought about
Hmm.
storing that somewhere in non RDBMS, but faster in terms of accessing it? For example,
Actually,
NoSQL or big data.
actually, so in our case, we are using one thing that is student ID, which
Okay.
is allotted to us at the start of our curriculum. That is in the first semester. We
Hmm.
are performing all the operations based on that student ID. So that is one thing which is not getting updated, but is accessed frequently. But so we have not thought about storing it in a non-RDMS thing.
Okay.
So currently, no, sir.
Okay. Thank you. Suhas, any question?
Okay. Just a quick question without taking any support.
Yes, sir.
Can you just tell me what is the full form of Moodle?
Modular Object Oriented Dynamic Learning Environment.
Yeah, thanks. Because sometimes what happens is once we do the entire project, we just forget, the nitty-gritties. I don't have
Yeah,
any
yeah.
question per se. Just a feedback. Moodle is a very good system, and it's good thing that you have worked on something quite practical. It's definitely very lightweight, and I don't know whether you have tested it, but it can even work on if you have a shared website or something. The Moodle will easily integrate with that cPanel or Plex panel. So you don't even require a dedicated server for that purpose. Are you using Moodle in your college also?
Yes, sir. Yes, sir. We are using it for the last 10 years.
Okay.
In our college.
Okay. That's really great. Fine. Thanks a lot, guys.
Thank you, sir. Thank you, sir.
Great. They all are plus? Yes. Okay.
Hello. The fourth paper for today goes by the title Intrusion Detection Using Keystroke Dynamics and Pi Membership Function for Web Applications. The authors are Professor Mahalakshmi Sridhar, Amok Joshi, Dwarkesh Nayak, Udyan Srivastava, and Vinesh Dias. The paper ID is IT036.
Yes, sir.
Sir,
Hello, sir.
actually, we are not ready yet with the PPT. Just give us 5 minutes. Yes, sir.
Yes, sir. 5 minutes, sir.
किधर है PPT?
Yes, sir.
Yes, sir. Yes.
Stand by.
Hello everyone. On behalf of my team members Dwarkesh Naik, Amok Joshi, and Venus Dias, myself Udyan Srivastava, we are presenting you intrusion detection using keystroke dynamics and bi-membership function for web applications. Our primary mean of authenticating the users in these days is password, which are convenient actually. But what happens is that users frequently share password with others. They sometimes forget password, and sometimes they select very weak passwords. So passwords can be compromised on daily basis. Currently, intrusion detection for password is done using encryption methods and biometrics. Biometrics includes fingerprint detection, retina scan authentication, and many other ways like face detection also. But the system we mentioned right now to detect the intrusion for passwords can be compromised, like encrypted data can be hacked by various means. Fingerprints can be compromised while the retina scan system is costly, and you have to carry that particular hardware every time wherever you want to go and authenticate yourself. Now the system we have developed has been acquired from the basic need of proposed system, that is to provide security to users who do online transactions and online banking. So there is higher risk of the password being stolen, and there exist many flaws in biometric systems. Suppose
if you're going in for fingerprint detection, maybe your thumb is injured and you cannot access your account. So that is one of the major drawbacks that we have handled here. So to overcome this problem, we have implemented keystroke dynamics. Now, what is keystroke dynamics? Keystroke dynamics are the patterns or rhythm and timing of the timing created by the person to type a password. Everyone has a unique way to type the password. Some people press the key for a longer duration. Some shift between keys very frequently. So we recognize an actual user's time quantum of key presses, so that it can be stored and a signature can be formed. Now this signature includes overall speed of the whole password, variation of speed moving between the specific keys, that is between the two key presses, what time is taken, and the common error that a person usually makes. So to develop a web application that forms the signature of an authentic user's password using his typing pattern, this being a unique biometric feature, would prevent an imposter from accessing someone else's account in spite of them knowing the password. So the main advantage we have is that even if you know my password, you won't be able to access into my account, since your typing pattern is far different than my typing pattern. Now the feature sets that we have included are enter key. Some people use enter key to log in and some use mouse click. Then there is key up, key down. Now this key up, key down is the amount of time for which a user has pressed the key and released the key. So key pressing is key down and key released is key up. Then there comes key down and key up. This key down and key up are the navigation keys that we use on daily basis to shift between the text fields. Then there comes shift key. That is, a user may use shift key to type the capital letter in his password. Some use caps lock key, so caps lock key is also included in our feature set. Then there comes mouse click. Some people use mouse to click on the login button. Some people directly do it by pressing the enter key. Then there comes the total time. This is the total time that a user takes to type the password. We have implemented a project on internet, and we have also included the tab key in it using fuzzy logic membership functions. We have studied around in total seven membership functions, which were triangular, trapezoidal, Gaussian, bell, segment, left, right, and pi membership function. We chose to go with pi membership function since it has very low FAR and FRR. FAR is false acceptance ratio, that is a false or an imposter or an intruder is accepted. The ratio of that was found to be 0.05, that is efficiency was 95%. And FRR, that is false rejection ratio, that is an authentic user was rejected by the system, that came out to be 0.0, that was 100%. The FRR and FAR of Bell and were quite close, but we chose to go with pi membership function since it is hardware independent. That is, if you type it from one particular PC, the keyboard won't affect the performance of the membership function even if you type it from another keyboard. So we chose to go with pi membership function. The main advantage of our intrusion detection system, and as compared with other detection systems such as fingerprint and retina scan, are as follows. The cost of our system is quite less than the other two. We require only a normal computer keyboard and not any other dedicated hardware for our system. The advantage is that we have high accuracy. It is hardware independent, as I told you that pi membership function is hardware independent, and it has high mobility. You can find keyboard anywhere, on any computer. The disadvantage is that we haven't implemented it yet on mobile system, and it is not available for touchscreens. So we found that our system came out to be highly accurate system with dependency on network connectivity. We studied around some papers and some research papers, and we found that when number of trials were taken, suppose 50, 70, 80, and 100, all the membership functions behave differently. And for all the membership functions, pi membership function, as I told you, came out to be outstanding. and you can see for 50 trials it had some significant amount of FAR and FRR. Then it came down as the number of trials increased. So now we have found that 200 samples, it performs best at 200 samples, and we don't need any more sample space than that. So the pi membership function came out to give us 95% of performance in FAR and 100% performance in FRR.
Our system is divided into 3 modules: enrollment process, login process, and adaptation module. Enrollment process, first of all, needs the user to log in 200 times so that the software understands what are the timings and what are the patterns of the user. The patterns are recorded into database, and a specific signature for the user is formed after 200 samples. In the second login process, after the signature is formed, the user types his password, and the server captures the keystroke timings. First thing done is it validates the username and password like traditional systems. If the username and password are found to be matching, then the keystroke dynamic systems comes in picture. The keystroke dynamic systems then validates the feature sets with the signatures, with that stored in the signature. After the login process system, the third module is adaptation module. That is, we want our system to be self-learning, but at the same time, we don't want too much space to be stored in database. That's why the adaptation module, what it does is, if the user is accepted in the login process, then his timings will be merged with the corresponding signature, with the particular signature, so that the signature will be updated with help of the current template, but the template will not be stored in database. The algorithm proposed, as said, is pi membership function, and here are the mathematical formulas for the pi membership function. X being the current time, and we are considering the average time for 200 signatures and the standard deviation of the 200 signature. So the 4 values that are considered here are A, B, C, D, which, as you can see in the screen, are average time minus 2 into standard deviation, which is A. B is average time minus standard deviation. C is average time plus standard deviation, and D is average time plus 2 into standard deviation. The user is directly accepted if the value comes between B and C. Otherwise, the formulas are used as shown in the screen. We are this is the implementation screenshot of the project. The user interface looks like this.
Can you
after we enter,
can you go back to, before going into the implementation part, can you go back to the architecture slide?
Yes, sir.
Can you explain the adaptation model once again?
Yes, sir. In the adaptation model, we don't want the extra signatures to be stored in the database. That is, as we said, that there are 200 signatures required. But if we keep storing on more signatures, then there will be a large space will be wasted in the database. So what we are doing is, we have calculated the average and standard deviation for 200 signatures, first 200 signatures. After the 201st signature comes, we will directly use it for the updating the signature table, but we will not store it in the user data table, regular database. So that's why we will save space. At the same time, the software will be self-learning, as the signature will be updated so that we can improve more accuracy.
Okay. Go ahead.
So as I'm going to implementation, the user interface looks like this. If the user is accepted, then it shows. If the user is rejected, then it shows intruder alert, and accepted, then shows successful. Here is the console screenshot, so that we can see on the client side the timings are captured. In the database, this is the user data table where we store the values. 1, 2, 3, 4 are the values for key press timings in the database, and enter, mouse click, shift, caps lock are the feature sets. If you press enter, then mouse click will be 0 because user can use only one of them. Corresponding values will be stored in database. Username, password. This is the signature, which has username, password, average time of the first key for 200 signatures, and corresponding standard deviation times for those keys. We have designed the web application for validating user based on behavioral biometrics, more specifically keystroke dynamics, that is through the typing characteristics. We found out that our system's efficiency was found out to be 94%, and the table shows the FAR and FRR results for the users. These are the references. Thank you.
Yeah, you stop the screen and yeah, I think you have done that. Okay, great.
Yes, sir.
So a couple of questions. Okay. One is, have you considered, or the current architecture considers a typing style, okay, of a user? I have, let's say, typing style, meaning after certain years of using the device, okay,
Yes.
there is a standard way of typing anything, right?
Yes.
Which is common. So keeping all fingers at standard places, or at standard keys, is a regular habit
Yes.
of those people, right? So it is a typing style. So that is a
Yes, sir.
similarity that you may found across the users. Okay, so
Yes.
is that the factor that is going to play important role for FAR and FRR, and how you cope that?
Yes, sir. Yes, sir. Typing style we have considered that is considered for the first 200 signature. The users, we have given enough room in the system for the user, so that even if there are any changes in the typing, it depends on the mood as well. So if the user types differently when his moods are different, so those all are accommodated in the first 200 signatures.
Right. So typing style changes after, as I said, okay, after certain time. So first 200 storage, right, may not have accurate typing
Yes.
style considered, right? That's why I asked
Yes.
about
Okay.
adaptation
Yeah.
module. Okay, so adaptation module,
Yes.
when it is updating signature, have you made any provision that it will also check that typing style is changed and it is now standardized, and therefore I need to actually update the template?
No, no. We have not considered updating the template. We have just considered updating the user signature.
Okay, so that is one. Another is, as you mentioned, device type. Okay, so device type, take example of laptop. Keyboard
Yes.
layouts are not that standardized. Okay, so device type also will play a
Yes.
role. So let's say I have a typing style with Lenovo ThinkPad. My typing style will change if I move to migrate to Dell or HP, right?
Yes.
So
Yes. Yes.
so how you are going to cope up with that particular challenge? See, all these are
So we have
improvements. Yeah, yeah. Go ahead, please.
so we have a particular amount of tolerance rate for our signatures. That is, if there is a slight variation in the signature, it will be tolerated within a given limit. So that can be accommodated in our Pi membership function. It doesn't need to be exactly same as it is stored in the database. So there is a given buffer, or you can say a tolerance rate for every user, and that is generally accommodated in all types of keyboard, and the rest will be taken care by the Pi membership function.
Agreed. So that is where I mentioned, since FRR is 0.05, and especially when we are detecting or authenticating the users on a password basis, uh, the aim has to be FRR should be 0.00. Okay, because you don't have to, you can reject. Okay, and
So this,
yeah.
sorry, sir. So this FAR and FRR that we have concluded are of the first 200 samples. As we know that our system is self-learning, so as we keep on incrementing and updating our database, as our system learns more about the user by time it spends with that user, so our FAR and FRR will keep on increasing. Our FRR is already 100%, and FAR will also increase to 100% from 94%.
Right, and that is where you need to update template at least in between. Okay, you cannot just keep 200 sample and then stop updating the template. After regular interval, you
Yes.
go back and change the template.
So we are regularly going to change the template.
Yes.
Okay.
That is what we will do.
Right. And I have one more question. One second. Okay. Feature set you mentioned, right? So in feature set, what is the correctness? Okay, in terms of features, for example, the timing that I use for pressing the key, right? Or
Yes, sir.
because that also varies in terms of smooth keyboard versus hard keyboard, right? It again based on the devices. So
Yes.
have you parameterized the variation that you may expect, in the pi member function, that this is a deviation, and is that something configurable?
So actually, you about the point about different hardware, we found out in literature review that the pi membership function, it does not affect if the user uses different hardware when it comes to pi membership function.
Okay, but
That is why I chose it over bell membership function.
agreed. See, the thing is, if I'm using laptop regularly, laptop keyboards are smooth, right? If I switch to desktop,
Yes.
desktop
Yes, sir.
keyboards are very hard. So
Bit
then,
harder. Yeah.
right, and therefore, if I switch on desktop, let's say for 1 day or 2 day, I may end up
Sir.
pressing the keys hard because I am not used to, right? Though pi member function doesn't consider theoretically that is, but practically that will affect, right? So think
That is
about,
why, sir, we have.
yeah, go ahead.
That is why we have a tolerance rate,
Right.
so that if there is a little variation in the timings, it will be accepted by the user. And since we are collecting 200 samples, so it is obvious that the user will use different kinds of keyboards. Suppose, because he won't be entering 200 samples in a day. So suppose if he is entering around 20 samples from his home laptop one day, then after 2 days he went to office and he used his office computer and he entered 10 more. So like this, all the keyboards in his vicinity will come into play, and all those features will be already stored in our database, all the timings of all those keyboards. Since that is, and that will provide us some kind of buffer, and plus we have added some tolerance rate also. So I guess if both of them are combined, it will give us much better result on different keyboards also.
Fine,
Yes, sir.
fine. Okay, thank you. So, has any question?
Just one question. Understanding keyboard and personal dynamics, which is basically your topic. Many organizations are trying to look into this particular aspect to make their systems user friendly and user intuitive. What
Yes.
work is being done at a global level? Can you throw light on it?
Sir, it was first tried in during in 20th century. It was first tried in, and
I'm
I
talking
think
of the developments in the recent few months or years that way. I mean, what is already being done that I would like to know in this particular area?
So right now there was nothing done based on keystroke pattern recording keystroke patterns or making signatures. What was done to authenticate e-transaction was OTP, that was one-time password and all. But the drawbacks was that if somebody is using an OTP and by chance they don't have signal in their mobile phone, it went in vain because they cannot receive the OTP and forward their transaction gateway. So this is one of the unique things. Until now, all the membership functions were studied. They made many membership functions, Gaussian, triangular, and all, but it was not implemented to secure e-transactions. So this is for the first time that we have done something to secure e-transactions and to authenticate user using keystroke dynamics.
Okay.
But Pi membership functions were studied.
Okay. Thank you.
thank you, sir.
Thank you, sir.
So our next paper is On Road, a car application, and the authors are Professor Anaga Sastry, Garrett D'Souza, Shannon D'Souza, and Akila Khanpuri. The paper ID is IT017.
Hello, Jared.
Yes, yes, sir.
Start sharing your screen.
So yes, 1 minute. So yes, 1 minute. It's coming. So okay, our topic for today is On Road. It is a car assistant application, and it is written by Akila Khanpuri in collaboration with Garrett D'Souza, Shannon D'Souza, and also our project guide Anaga Shastri. The problem statement: when we looked at the cars, we thought, why not let's connect a smartphone to it? We use our smartphone for a lot of things, and we thought let's use our smartphone and connect to the car so we get some useful information from our car, which led us to the topic which is on road. However, when we saw the car and we saw the smartphone, there was no way to connect it directly. So we decided to use an OBD2 adapter or an onboard diagnostics tool. The need for the proposed system is we want to
Jared,
Yes, sir.
I can share your screen.
Yes, sir. 1 minute. Do we start from the top?
Yes.
So can you see my screen?
Yes.
So yeah, so this is a paper. It's called On Road, which is a car assistant application. With the help of this application, we want to use Android phones to connect to a car. This cannot be directly done, so we decided to use an onboard diagnostics tool. The basic problem statement was that we wanted to connect a car to a phone, but this was not directly possible. So for this, we decided to use an ELM327, commonly known as an onboard diagnostics adapter or an OBD2 adapter. With the help of our system, we wanted to provide a driver gear changing instructions, provide breakdown assistance, provide logs for fuel consumption, mileage, and also help the user to schedule various services such as PUC, a service scheduling reminder, as well as car insurance reminders, also to help locate cars while parked in heavily crowded areas. This is the basic structure where the OBD is connected to the car and acts as one device, and the phone, which is connected to a SQLite database that is provided in the Android interface itself, and they connect to each other to work as one cohesive unit. About the EM327, it is a very commonly used OBD adapter. It is cost anywhere between 700 to 1,000 rupees. And also, as of now, it supports only Bluetooth 2.0 and not the new low energy Bluetooth standards.
For software, we recommend our users use the latest version of Android Lollipop, which was introduced by Google at Google I/O 2014. It uses Project Volta. So, as I said before, Bluetooth 2.0 is the standard which OBD uses, and that cannot be that is not very power efficient. So for all the background applications, we use the Job Scheduler API, which is used in Project Volta to connect to do all the background activities. We also have Android Runtime, which provides garbage collection on a activity basis, which helps us run the multiple threads which we run during the application efficiently. Material design helps the UI look much better than it would actually look as compared to the Holo theme, which was present on the previous versions of Android. It helps provide a better UI so that a user gets a much more easy experience. We have used material design throughout the application. Next is Android Auto. This was a feature promised by Google in their I/O 2014, but has not been out on any cars yet. So when it does, our app will fully support Android Auto. We have 10 features that are listed here. We will be talking to you today just about the top 5 features. First is our parking location tracker. The parking location tracker basically looks to see the moment your phone gets disconnected from the Bluetooth of your car, which helps and it stores the coordinates. These as you can see on your screen, it will provide the user with a notification. On accepting that notification, the coordinates are plotted and the car, and with the help of the Google Maps API, you can find your way back to your car. Next, the main cause of accidents is talking on the phone, and we thought, why don't we solve this problem too? No talking while driving is another feature of our car, which checks if the engine RPM is greater than 0, that is your car on? So if your car is on and the feature is enabled, the call will not be received. As you can see here, it blocks incoming calls. The notification appears in the bar, as you'll see in the slides below, and it provides a whitelist features which are available that allow certain calls to come through. As you can see on the first video on the left-hand side, the call gets blocked, and the notification that I mentioned earlier is there present, which tells the user that incoming calls are blocked. And second and the third notification, the incoming calls is disabled and you can easily get a call. Next, we have the gear change indicator. This enables drivers to efficiently change gears and allow them to change gears on time. The RPM, this is not a very accurate thing, but it will give a near definite experience to when to change the gear through voice feedback. As you can see, it shows the engine RPM as well as the speed, and for every gear change, it sends a voice command which allows the user to get to change their gears. We have your fuel top-up logs. This feature does not require any OBD connection, but it helps the users to maintain a detailed layout of how much fuel they've consumed for a month as well as on the whole for a week. This is done through graphical representation. It shows the fuel consumed for the month as well as the money that is being spent on fuel. Breakdown assist was one thing we thought which would be very important for us, so we tried to include it. Vehicle breakdown assist includes an SMS to 3 emergency numbers, which sends your location and as well as a call to the nearest call center, service center. As you see, my service center of choice is Fort Point, and when I click on it, I will be directed to a call towards them. Also, on the rightmost screenshot, as you will observe, there is an there's a SMS that is being sent, and as well as with the Google Maps location. In future scope, we would like to do route optimization, as that is to provide the best route for travel for a particular journey. We wanted to work with Android Auto. As soon as more cars come out, that will help provide us to port our app over to Android Auto, which will bypass the need for a phone. And gamification, in the sense, if you have multiple users who can drive more efficiently from one journey to another. Thank you. Our app will be later released in the summer on Google Play. It's a free application. Thank you very much.
A very practical and useful app. Hello. Can you hear me? Yeah. A very practical and useful app. What I wanted to know is, out of all the features, the feature which interested me the most was disabling calls while driving, and at the same time allowing calls from some specific important persons. My quick feedback, I mean, when I am driving, if I get a call, yeah, when I am driving, when I get a call, the first thing which I worry is this call from some important person, and I am focused onto that. So I have to just park my car somewhere on the side and take the call and keep it up. So looking at it from a practical point, I think apart from all the other features, this feature can be something which is quite useful. Of course, the other features.
Yes, so we also have drive logs, which wasn't showed here because we didn't have a video. The video streaming isn't possible, but our drive log basically records the idling time, which tells you how much of time you wasted.
Wasted in what?
It is basically
wasted in what?
We help. It basically helps the user to gauge how much distance it's traveled.
Mm-hmm. Okay.
So we
okay, fine enough.
So any more questions?
Okay, one thing is about that OPD which you said, which you install in the car. Is it commercially available easily? I mean, where do you install it?
Yes, it is commercially available.
For
it is not available on Flipkart, but you can buy it on Amazon. You can buy it on eBay, and it works with every car post 1996, which I'm sure was pretty much all the cars.
But where do you install it?
So it goes under the steering wheel. It's a 16 port. It all 16 pin port, and it acts like a USB device. So you plug it into your car, and it transmits data via Bluetooth.
Okay. One practical problem which I am anticipating. See, cars usually have their stereo systems and all their electronic gadgetry. Whenever a manufacturer gives you a car, he gives you with the caveat that if you try to tamper with their electronics, the warranty can become null and void. So if you are going to introduce some gadget,
so this is not tampering with the electronics. So this OBD device is used by the manufacturers themselves to test whether there's any problem with your car.
Okay.
It connects to the ECU of your car, and it does not interfere with the working of the car at all. It just acts as an interface for you to get data, as basically like a streamer.
Okay, basically I can understand it's a read-only device which will transmit data to your phone and it will give you that. So I was wondering where are exactly placing this particular device, and whether it will have any implications on the warranty aspect that way.
So no, it doesn't damage the car at any point.
Okay, just make up.
There is no harm done to the car.
No. What I would give a practical, suggestion is just make a quick check with the car manufacturer that by putting this device in your car, will there be any impact on the warranty of that car? Because it shouldn't happen that people use this device and later on, if they have any issue and the manufacturer says, "Boss, this is some kind of device which have been inserted without our knowledge." So your warranty is impacted or something like that. Just have a check so that all these aspects don't be a problem to the customer. Okay?
So there isn't a problem because we are not sending data to the car. We are just receiving data. It's one-sided data. There is no data being sent to the car.
True, but that is
the
what
data
you
is
know.
received from the car.
No, that's correct. But that is what you know. But a car manufacturer can use, even though he's convinced, he may still use this as an excuse to make the warranty null and void. So just try to understand the legal implications of introducing any kind of a device into a machine like a car, which goes into multiple lakhs that way. Just try to explore that initiative so that you're legally safe and
yes,
sound.
so we will have to talk to a bunch of manufacturers and see what they think about it.
Yes, because many times, see, any car manufacturer or the insurance will find ways to avoid giving warranty services or insurance services. So it shouldn't happen that even though your device is created with good intention, some people may use it, to harass the customer that way. Simple. Okay.
So yes, so it's a very valid point. We'll have to look into this. But again, this is a very free app. This is a free application, and it was mainly targeted as the lower end cars because we were testing on a Tata Nano and an Android One device. So it's a we aim for like the lower people who just want to gauge what's happening with their car. Because many a times when you buy a car, you cannot see fully what's happening. They've said my mileage is so much, but is my mileage really that much? How much of fuel I'm consuming over a month? So we wanted to have one collective app that will basically be a center for your car. So when you decide to find any information about your car, you can go to the app and you'll have all the information. It works on minimal hardware and the lowest end of lowest end cars.
Okay. Couple of questions from my side. Okay. You mentioned about OBD2 device, right? Have you studied OBD protocol?
Yes, sir.
OBD protocol?
Sir?
OBD protocol?
So protocol, as in they use 80, there are 8 protocols by different manufacturers.
Uh-huh.
You have to be specific.
Okay. So
which one do you want?
No, have you studied any of them? At least one.
So by studied, what do you mean?
Meaning how it functions. So okay, let me ask specific question.
So this is how it works. So if you want to know how it works, there are 2 types of commands you can send.
Yeah, I have one specific question about the protocol. Will it allow, okay, so it is just sending data to your Android devices or Android app, right? Will it allow to send it to a laptop or a server?
So yes, so it sends it. So it depends upon the mode of communication. If you've got an application that can connect to it, yes, it will.
Okay.
It can work with. It is used in garages as you have OBD to an OBD adapter that connects to a USB port in your car that gives diagnostic checks.
You mentioned something about job scheduler. Okay. Job scheduler.
So yes, the job scheduler.
Why you need that? Sir. Why you need that? You mentioned about something on low speed.
So as you see, for the gear shift. So I didn't catch you.
Yeah, you mentioned something about low speed in terms of transferring data, and therefore you explained you need a job scheduler, right? Can you explain a bit more?
No, so the job scheduler API is for backend work and for running threads.
Okay, can you explain it a bit more?
So so you see when we are running a feature like a gear change indicator, there is certain thread restrictions that Android have. If you go too much, you need to create a memory size buffer for it. So the job scheduler API basically as checks whether you are connected to a power source or not, and helps me in such a way that it will move the buffer. So I have 2 buffers currently. One thread runs in one buffer, and at some point when this thread stops, it goes down and the next thread comes up. So when these 2 threads are moving between, the data has to be cleaned. And in case the OBD values don't come consistently, it helps to bridge this gap. Also, the job scheduler API is used for most of our backend work. So when you have to compile the database, because after a period of time, when more and more entries come into the database, more and more data is stored, we need to concise the data. So all these activities can be done later on in the night when the phone is connected, or when the phone is connected to power source. So we have certain conditions in the job scheduler API that help to do a lot of the backend maintenance. Mainly it's used for backend maintenance.
Right. Another is for fuel top up. Okay. Input, I believe, is a manual input. Correct?
So yes.
So have you thought about automating it by using some sensors?
So you can automate it, but as I said, it's for the basic consumer. So the features, the certain feature set, the OBD allows for it, but the car should have that feature to give us the fuel data. What we have done to make it a little easier is we've set up geofences using Google Maps around the petrol pumps, where you can, with the moment you're in the area, it basically gives you a notification that do you want to enter a log. So at that moment, when you're done filling petrol, before you start the car, you can enter your log and you're done. You can put it aside. So geofences is one way we thought of
So that is a recommendation
to
part.
combat this sort of.
Right. Okay.
So yes.
Yeah. I think I'm done.
Thank you, sir.
Yeah. Thanks.
Thank you, Gareth. Thank you.
The last paper for today is Visual Cryptography Using Half-Toned Images. The authors are Justin Albert, Samarth Suresh, Julius Rodriguez, and Ian Menezes. The paper ID is IT038.
Good afternoon, sir.
Can you hear us, sir? Yes, sir.
Hello.
So can you hear us?
Yeah, Julius.
Yes, sir.
You can start your presentation.
Okay, sir. A project is visual cryptography using half-tone images, and it's presented by Samarth, Julius, Justin, and Ian. Okay, talking about visual cryptography, this is a technique wherein only visual information will be encrypted. Now, usually in traditional cryptography techniques,
such as like say AES and DES, there is like usually multiple steps that are performed iteratively in such a way that the time complex that many steps are implemented. This kind of is a strain on the resources and takes a lot of time as well. Okay, visual cryptography on the other hand does not encrypt one character at a time. What it does is it could basically encrypt any sort of image. It could be
Can you
like a set of
navigate your
numbers, it could be-
presentation? Navigate your
Sorry?
presentation.
Um, yeah. Yeah, this is the first slide, but it's a kind of not, there's an error that's coming. So it's the image has got replicated all across the screen.
Fine. Go ahead.
Okay. So visual cryptography, it will basically take an image. That image could be the face of anyone. It could contain characters, it could contain numbers, and it's basically going to encrypt the image in such a way that when you will see it, you'll not be able to recognize what the original image was. And using visual cryptography, what we'll be doing it is we'll be splitting it into multiple shares, such that you would need the shares to be overlapped in order to view the image. Okay. Now, this one going. Okay. One of the algorithms that we began with to implement visual cryptography was SBR, that's simple block replacement. Now, in this, what we have done is usually when we look at an image, it's usually a pixel that holds the color. What we have done is we've converted the image to a set of blocks, something like this, wherein what we are doing is we're dividing the entire image into a set of blocks. So this over here is one 2x2 block, and as you can see, it contains 4 pixels. Okay, so we are dividing the entire image to a set of these blocks. Now, these pixel values could usually contain black and white pixel values, and that is what we have implemented on. So as per our algorithm, if this pixel count in the block is either greater than 2 or equal to 2, then the entire pixel block will turn to black. So if, like in this block, if there are 3 black pixels, or even if there are 2, this entire thing would be black. If it's anything less than 2, then it would turn to white. And the output is shown on the next slide. This is what we have taken is a half-toned image. And when we have implemented a simple block replacement on it, this is how the output looks like. As you can see, it's not entirely clear, and most of the image is darkened, which is why we have implemented a modification to it. And there are 2 steps to it. The first is the balance block replacement. Here, apart from dividing the entire image to a set of blocks, we are also including a 4x4 cluster. That is, we'll be considering a 4x4 cluster, which will consider 4 blocks at a time. That's again shown over here. So as compared to SBR, there are 2 additions to this. One thing is it will take into consideration the neighboring blocks as well. It will see their values and accordingly change the current block values. The other addition is, as per the algorithm over here, as you can see, it is similar to SBR. That is, if it is greater than 2, it will if the number of black pixels in the block, if that is greater than 2, we convert it to black. If it's less than 2, we'll convert it to white. Now in SBR, if it was equal to 2 as well, we converted it to black. However, in BBR, that's balance block replacement, if it is equal to 2, that is when we will take into consideration the neighboring pixels. Okay. Then what we do is we plus 2 or minus 2, that is either convert the block to a white block or to a black block, and we'll see how the difference is being maintained. Okay, if this difference is altering as per the original cluster black pixels, that is in this cluster, if it's getting modified as per that, the black, making sure that the total number of black pixels in the cluster is somewhat maintained. Which is why this difference is being calculated to make sure that the least difference is maintained between the original and after the conversion. The output for this is also shown. Again, this is the same image. This is again the same half-toned image, and the one on the right is the BBR output. Okay, as you can still see, it's still not that clear as compared to the original image. Okay, so to this we have taken one more modification, that is, apart from the basic algorithm that was implemented in BBR, we are now overlapping the clusters. So if this is your first cluster, then your next cluster wouldn't be this one. It would overlap the first two blocks from the previous cluster. Okay, so as per this image, what we have done is for our 8x8 block, we have divided it into a set of 9 clusters, and the number that you can see mentioned is the initial number of black pixels that it holds. As per this, we have modified the algorithm and then applied BBR, and then the output is seen as this. Okay, as you can see, it's clear enough to still make out that it's the picture of a bird. And comparing it with the other algorithms, this is how yeah, it's coming. So can you hear us?
Yes.
The presentation. Yeah. So we were just talking about. Yeah. Okay. Yeah. The modification that we implemented to BBR to suit overlapping clusters, and this is how it looked like. It's an 8x8 image that's encasing 9 clusters, and the initial number of black pixel is what is the numbers that you could see on the slide. Okay, the output of this is as seen on the right. This is the original image, and the image to the right is the BBR overlap output. Okay, comparing it with SBR and BBR, this is the difference. The SBR image is way quite dark to actually make out what exactly is hidden in the image. BBR is fairly clear, but compared to BBR overlap, it's very much clear, and it's clearly visible that it's a bird. Okay. The next part is the splitting of the image as to how the shares are made.
Okay, now what we implement to do after this is we will take the pre-processed image either by SBR or BBR, and we'll be further dividing it into shares such that when you see the shares individually by themselves won't make any sense. But when you take a printout of the shares and overlay them one on top of the other, you'll be able to get a representation of the image. Now, the first scheme that we implemented was a 2x2 scheme. Basically, what we are doing is we are taking up each and every block and we are splitting up into 2 parts.
Sorry?
So we are splitting up the image, each and every block into 2x2, into 2 parts, where if we are having a white block, we'll be splitting it up into 2 shares. Like for example, when you see on this, as you see on the slide, considering a white block, both the shares have the same configuration. Whereas if you see the black blocks, one configuration is just the opposite of the other. So if we take into consideration, we have 6 different combinations for white and 6 different for black. So basically, when you divide it into shares and you overlay the images, the white block will appear as 50% white and 50% black, whereas the black block will appear as a completely black block. Now, this was a part of the experimentation that we did with the scheme. For the first time when we implemented the scheme, we got the shares as you can see them on the screen right now. The first share is like totally blank, and the second share gives the outline of the actual image. Now, the problem in the scheme was that the first share was the same for whatever image we operated the code upon, and the second share would always give the silhouette of the image. Now, this is the final implementation of the 2x2 scheme, whereas you can see from the screen that you can't make out the image from any of the 2 shares, but when you overlay those 2 shares, you'll get the actual image or the pre-processed image that we have been feeding to the scheme. Now, the 2x3 scheme is a further implementation of this project, where we aimed at splitting the image into 3 shares, whereupon after overlaying any 2 of these 3 shares, we would get we obviously wouldn't get the entire image, but a somewhat representation of the image. Now, the printouts, when we took this, the printouts came large, and the problem is we have implemented this project only on 256 by 256 image, because the codes that we are using are taking high amount of resources in terms of cache and processing memory. So on overlaying these 2 images, you don't get a clear representation, a somewhat better representation of the image as compared to the original image. So do you want to see the output of the codes?
Yes, yes.
So if you see this, like when I'm overlaying the 2 shares, you can see something called 0101 on the image. But this is after while overlaying. So if I split the 2, it doesn't make any sense because the 2 shares are totally different. So when you see the shares separately, you can't make out the actual image. It's only after you overlay that the images pixels match each other and you can see the image again. So this was a 2x2 scheme that we have implemented. So this is as far as we have gone in the project, and we conclude to say that like the basic aim of our project was to implement research and find out which schemes would give a better output as compared to each other. So what we found out that the 2x2 scheme what we implemented gave a much more clearer output as compared to the 2x3 schemes. And we had actually planned to implement the further schemes also, like we would split it into more than 5-6 shares and see combining about 2-3 shares from them. But then we realized that if we implement those schemes, we would have to increase the size of the block, which we have currently taken as a 2x2 block, and that would ultimately lead to pixelation of the pre-processed image as the block size would increase. So the pixels would enlarge themselves in the pre-processed image. So what we have concluded is that the 2x2 scheme is the best as far as possible as what we have implemented.
Sorry, I think it is a systematic implementation and analyzing the existing schemes. Okay, and so far whatever two schemes you have compared. Tell me one good application of this.
So if you take the 2x2 scheme, one good application that we thought of was authentication. Like suppose, for example, a bank or any other organization needs to authenticate a user. So what we can basically do is we can divide the image into shares, whereas one share would be kept with the organization and the other share would lie with the user. So in order to authenticate the user, you just have to take the share from him and simply overlay it with the shares that you have. Now, because the good part of this scheme is that if you take one share from any other image and overlay it with the other share of a different image, you won't get a possible output, because what we are generally using is a random sequence of numbers which decides what combination of splitting up the block to use. So basically it's a stream of about 128 into 128 random numbers. So authentication was one application that we could think. Also, if we have to send a highly secret message to someone, what we can basically do is we can write the message on the image and split it up into two shares, whereas one share will be passed on a secure line and the other share on a normal transmission line. And to decipher the message, you have to overlay those two shares, get a printout of those two shares, and overlay it one over the other to decipher the message.
Okay, taking example of authentication, okay, for a bank,
yes,
how it is different than let's using MD5 or Kerberos authentication or 128-bit authentication? How it is different? And what
we actually, by visual cryptography, we actually mean.
Yeah, go ahead.
So by visual cryptography, we actually intend to reduce the operations that are operating on the deciphering end, like decryption algorithms. Basically, what we see in the current techniques is that the encryption and the decryption process take up a lot of time, as well as resources in terms of hardware or software resources. Whereas in this visual cryptography, only we have to first split up the image into shares, whereas the decryption is only overlaying the shares, where we don't take into consideration into use any computational resources as such.
Okay, what will be size of one share in bytes?
So basically, we are operating on BMP images. So the size of one share is about 26 to 25, 30 KBs.
Okay.
Since we are only operating on binary images.
Okay. So how you compare that, okay, versus the time requires to decrypt? So you need to compare two parameters. One is the size of data getting transferred, and second computational time for encryption and decryption. Two parameter it needs to be compared. So have you compared those? I understand your project is for, or a paper is for visual cryptography, but again, uh, when it needs to compare with existing mechanism of cryptography like MD5 or 128-bit or any other, right? Have you compared those?
So we've compared it only in terms of the technique as to how it has been encrypted. Like you just mentioned that the number of steps in the other techniques is kind of a lot. Whereas compared to what we have implemented in visual cryptography, we have focused the steps only on the encryption side. If you notice in the decryption, we just need to overlay the two images. We don't need to like sit and take every character into account and keep decrypting every character that comes next in our message. We have to just overlay the two shares and the entire message is seen.
Okay, thank you. Suhas, any question?
No, nothing at this stage.
Okay, thank you.
Thank you, sir.
Uh, on behalf of the IT department and all the staff, I would like to thank you all for joining us in this event and making it a huge success. And I hope that all the participants benefit from your positive reviews. And may I now request our HOD, Prasad sir, to give you all momentum to Mr. Vinayak sir. May I now request Tayyab Ali sir to hand over memento to Mr. Suhas.